basically we are going to just we are going to be looking at the wiring of the PLC side for today. Later on, when we proceed to our HMI course, we look at the HMI side, and then when we get to the application examples as well, we are going to consider them. So it will be stage by stage. So everybody should open their kits right now. Please, everybody like to move away. Okay. Can we come together? Let's come together.
What do you need money for?
They just bring out some of they bring out some of the candidates. Really, this is another I mean, this is anyhow, this connector, okay, that's connector, and the way it was designed, you can see they use different colors. Like I said, in the sub there, you see different cables in there as well. So the idea is that you use the cable color that you have to do connections. So any of these connectors that is yellow, you connect it via the yellow cable. And then for the lens you use the blue cable, for the lens you use the red cable, for the black you use the black cable. So if you look at the way this is designed, you can tell this is what red, and then what do you see here? Also, so it simply means that all these guys are red is having positive to and then the black is signified by the negative, the 0 and then you have the blue as the ground. And then now we use, in this case now, we can see we use yellow for the digital input, and then we use green for the digital out. Okay, I will say in the case of this one now, you cannot really tell whether we can really tell whether you are doing syncing or you are doing sourcing with this kit. The way you check the wiring diagram of the details, you will be able to tell the difference. So for this class, we fire it as it is here. Okay? So first, we need to power this kit, and can be powered with 220 volts. There is this from here for the 220 connection. the power cable, this is where we are going to plug in the power cable, the 220 power cable for the whole kit. So, like I said, it's you don't need to be told before you know that this particular line is a PLC without 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 screen. Yes, it's without screen. But at this stage, we are talking about so this PLC is what
No, no,
is a PLC without SSD. So, and if you look at the relation here, you will see CPU 12 remains DC, DC, DC. The first DC is what signifies the power that comes into the PLC. So, and in this case, that is what is coming into the PLC is 24 volt DC. So, there is an internal power supply in this system that helps convert the 220 volts down to 24 volts. Now, the second DC we were asked, what's that one for? It means that any form of input device that you want to connect to this line has to be a 24 volt DC as well. And then the last DC is also to show that any form of output device that you are connecting to this PLC has to be a 24 volt DC. You can also like AC, DC delay. It means it is going to take in 220 volts. That's why it is AC. DC, it means the input device that connected to has to be 24 volt input. Okay? And then the last one of RLY, again, it means we are at liberty of using it as you wish. You can connect the 220 volt device to it. You can connect the 24 volt device to it. So that's DC is the power, it's our power, not the system. Still, it does not state whether it's physical input or digital output. All right. So as it is now, this system is powered, and it is expected that at this particular point, we will have 24 volts DC. Okay. So we now use this 24 volt DC to power the CPU. Okay. The question is, we want to power this system. Where are we going to connect the power to here? And we have established that it's going to be there because I think I want to use it because the CPU now the question was asking them, is it here or here? We're going to connect this. So the mindset so now we are going to connect it here. Before connecting, I'm not going to tell you the difference between these guys and where they are actually coming from. Now look at this one. So please come to you will see an arrow that is pointing at inward. That is pointing towards this direction. So that is the input. The input supply. The input power supply to the field. Okay. There's no more input power supply to the field. Now there is another arrow pointing out. It is showing 24 volt output as well. So it is this input to the PLC that is brought down to this one. And it's this output that is brought down to this one. We see something like L plus N. This is the L plus N. And this is ground. This is the ground. And then you have this L plus N. This is the L plus N. Okay? So is this clear? Now, there is something you need to take note of. There are three entities here. There is the first one is the run and the stop. The next one is the error, and the next one is the maintenance. Okay. So the run and the stop is to indicate whether the PLC is in run mode or in stop mode. Okay. So if it is in run mode, it will turn green like this. If it is in stop mode, it will be maybe yellow. So if it is in stop mode, it will be yellow instead. Now you see this error LED that is where you can see there is another LED that is blinking here. It means there is a problem. Okay, so it could be an hardware fault, it could be a software fault, but that is not for us to discover in this particular class. Maybe when we reach the troubleshooting and analysis part of it, so we go into in depth into like what this means and what are the things that we need to do. So, okay, so you can, if you come closer, you will see that there is a particular output that is on at the moment. D0, the LED is on. The green LED is on. DQ. And you will agree with me that we have not connected any output here or any input here. So my question now is that why is this thing on? Who can tell me why this thing is on? This particular DQ, this output is showing that the particular output is on here. Why is it on? Even input is not on, but output is on. These LEDs you see here, this one they are for the digital input, okay, and this one are for the digital output. If you look at it, you see something like VI, and this one is showing DQ. So, and for an output to come on, there must be an input, right? So, because at the moment there is no input that are on, but there is an output that is on. So, I want the question I'm asking now is that why is an output on? What is this device? Isn't it as in the device? So what is it? PLC. What is it made of? Why are you calling it programmable logic controllers? So because you can program it, why is this output on? And it's making it on. That's the simple answer to that. Is that what you